We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It is now in a heads-down position on track for its flight to the International Space Station.
The space industry is growing like a building startup. Sending a rocket to space is not surprising as it was in the 60s and 90s. SpaceX, or NASA, is launching rockets almost every month, enhancing the human knowledge of outer space. Although space travel is crucial, it is costly, especially since launching rockets costs between $90 to $300 million, depending on the weight. Scientists have searched for ways to make the transaction more economical and eventually came up with an idea. So what is the space elevator? The space elevator is a system made to transfer satellites, computers, and other equipment from Earth to space quicker and cheaper. What are some benefits of a space elevator? There will be no need for natural fuel because the elevator will be powered through Earth's rotation. Sending a satellite with the crew costs $160 million, approximating $20,000 per kilogram. To send an average human in a space shuttle costs $1.3 million. But with the space elevator, the price will decrease to $200 per kilogram. On top of that, every country that's involved with space can use the elevator to send packages to the International Space Station. How does it work? The space elevator has 4 major parts for it to function effectively. Part 1. The anchor is the base of the elevator, which connects it to the Earth and carries the entire weight. Part 2. The counterweight will be the top of the elevator located in space and which holds up the tether. Part 3. The tether is like a rope that connects the two ends and functions to keep the structure balanced. Part 4. The climber is the device that moves the cargo from base to the top. A space elevator will be quite beneficial, but is it possible to make a space elevator in real life? In addition to the space elevator's parts, power is probably the most challenging factor. It requires a lot of energy, approximately 54 megajoules per kilogram. The average household consumes 3,157 megajoules per month. Diamond nanothreads and graphene are the materials that are being considered, but they might not protect the space elevator from all of the natural phenomenons. Is there an abundant amount of the correct construction material, or do new minerals need to be artificially produced to fit the job? Some experts suggested testing the idea on the moon. The moon will be easier to build on because the gravity is much weaker than the Earth and poses fewer safety factors. As scientific research excels, we learn and understand more about space and dream of the endless possibilities that can be achieved.